Alright, this is part 2 of a lesson reviewing quadratic functions. In this video we will focus on factoring quadratic functions. Now remember, quadratic functions are the ones that have squared in them, so something squared. So most of these are quadratic. These number 3 and 4 are not actually quadratic, they are linear. And number 6 is not quadratic either, but most of them are, so we're just, it's fine. For these first 4 problems, we just need to factor out the GCF, which stands for greatest common factor. Both of these terms are divisible by 3. So if we pull out that 3, that's going to leave behind x plus 3. Once you pull out a common factor, in your mind you should be dividing by that common factor to figure out what goes on the inside. So there it is. Now, what's the biggest number that goes into 8 and 18? I think it's 2 is the biggest number that goes in. So 2 is the greatest common factor, so we'll bring that out. But if we divide by 2, then that leaves us with 4y plus 9. Okay, so that's number 4. Now this one, again, the directions just say factor out the GCF, so focus on that. All of these are divisible by 3. And they don't have, the last term has no ends, so we don't have to worry about the variables. But, so the GCF is 3. And like I said, at that point, we are dividing everything by the GCF to know what will go on the inside. So that's going to make 2n squared plus 4n plus 5. Now, I'm looking at number 6. They have no numbers in common, but they do have variables in common. Both terms have y's. The first term has 4y's, the second term has 2. You have to go with the lower amount. Okay, we have to go with the y squared as the GCF. And your thinking is, okay, both terms have at least 2 y's to take out, so that's the most you can take out. But again, once you have the GCF, you are dividing by the GCF to imagine what goes on the inside. Y to the 4th power divided by y squared will be y squared. Y squared divided by y squared is 1. Anything divided by itself is 1. So don't put nothing. Some students will go, oh, those cancel out, so they'll just put nothing. But no, anything divided by itself is 1, not 0. Okay, so we're through with just factoring out the GCF. We have to do more for the rest of these factoring problems. We need to be able to factor a trinomial. So when you factor a trinomial, if it's going to factor, it's probably going to factor as a binomial times a binomial. That's 2 terms times 2 terms. Now, before you do that, you should always look and see if there's a common factor. So in my class, I will often ask my students, and I'll say, what's the first step of factoring? And they should all say in unison, GCF, because that's the first step of factoring. Always look and see if there's a common factor. This doesn't have a common factor, so we can move on. Now, the first number, first you look at the first term, a squared. A squared can only factor one way. That's a times a. Don't look at the middle yet. Next we look at the 27. A few things come to mind when I see 27. The first one is 3 times 9. Okay, so that's a possibility. But if that didn't work out, it could also be 1 times 27. But I guess that's it. 3 times 9, 1 times 27. Anyway, we'll go with the 3 times 9 option. But on a problem where that didn't work out, I would try the next thing on the list. So now is when we look at the middle term. And here's what you're going to hear me say over and over again. The inner plus the outer has to equal the middle. Alright, we have a middle of 12a, positive 12a. So inner, I have 3a. Outer, I have 9a. We can control the signs. Can we make positive 12a out of this? Sure, if we just leave them both positive, 3a plus 9a is 12a. So we'll just leave them both positive. Okay? Now, there are problems that we have learned where this would be the first step, and then we keep going by setting them equal to 0. And so then we get a equals negative 3. But sometimes we're just supposed to factor and stop. So is this a problem where we just factor and stop? Or is this one where we keep going and get negative 3? The directions just say to factor. We're not solving anything. So please, 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 just factor and stop. Don't go any further. Also, there's no equal sign. This is not an equation, so you couldn't solve it anyway. Alright, so that's number 7. Number 8, same type of thing. Y squared can only be y times y. Okay, don't look at the middle term yet. Next, I look at the 110. Now, I'm sure there are other things, but the first thing that comes to my mind when I look at this is 11 times 10. Okay, clearly 11 times 10 is 110. So let's go ahead and try that out first. 11 times 10. Now we can look at the middle. And remember, the inner plus the outer has to equal the middle. Inner, I have 11y. Outer, I have 10y. I can control the signs. Can I get positive 21y out of this? Again, yes, if I just leave it positive 11y and positive 10y. Okay, that'll make positive 21. Also, positive 11 times positive 10 makes positive 110. Always have to check that. So that's it for number 8. Okay, let's try number 9. There's no common factor, so we'll move on to the binomial times binomial phase of the operation. N squared can only be n times n. 4 is either going to be 2 times 2 or 1 times 4. Let's try 2 times 2. Now, inner plus outer has to equal middle. Inner, I have 2n. Outer, I have 2n. I'm trying to get a middle of negative 4n. Can I do it? Yes, if both of these are negative, that'll make negative 4n. So that would mean both of these would be negative. But wait a minute, will I get a positive 4 when I multiply these? Yes, a negative times a negative is a positive. So it works out. Okay, so that is the answer to number 9. Alright, number 10, still no GCF. So let's go on binomial times binomial. M squared can only be m times m. On the other hand, 33 is either going to be 3 times 11 or 1 times 33. Let's do the 3 times 11. Now remember, inner plus outer must equal middle. Inner, I have 3m. Outer, I have 11m. m. So I'm trying to get a middle of negative 8. Can I do it? Yes, I can. If I want a negative 8, I'm going to need a positive 3 and a negative 11. That'll make negative 8. So here's my positive 3 and here's my negative 11. Have to check one more thing. We have to make sure we're getting the right sign on the negative 33. A positive 3 times a negative 11 is negative 33. So this is the right answer. Alright, number 11. Again, no GCF, so I go on to binomial times binomial. Start with c squared, which can only be c times c. Well, 1 can only be 1 times 1. Now remember, the inner plus the outer must equal the middle. Inner, I have 1c. Outer, I have 1c. Is there any way I can choose the signs so that it would make negative 2c? Sure, if I had a negative 1 and negative 1, that would make negative 2c. So negative 1 and negative 1. Will that give me a positive 1 here? Yes, negative 1 times negative 1 is positive 1. Number 12. Alright, finally they get a little more interesting by putting a number in the front, a leading coefficient greater than 1. Okay, so still look and see, is there a common factor? There's nothing that divides evenly into all three of these terms, so we will still go ahead and go to the binomial times the binomial. Now looking at the 3x squared, that can only factor as 3x and x. Looking at the 10, 10 is either going to be 2 times 5 or 1 times 10. Now you might be thinking, oh, let's go with 1 times 10 because that can make 11. And let's go ahead and try that, but I'm betting that's not going to work out. And the reason why is because we've got this 3 in the front now. So in all the other problems that had no leading coefficient other than 1, you could immediately look at the 3 and the 11 and look for the 8. Okay? But that's not going to work now. We can't just look at the 1 and the 10 and try to make the 11 out of it, because we got to deal with this 3. And the reality is inner plus outer, including the 3, has to give us this middle. And the way I have it right now, inner is 1x, outer is 30x. No matter how I choose the signs, it's not going to make positive 11. So before I throw out the 1 and 10 option, I should try it the other way, with 10 here and 1 here. Again, inner is 10x, outer is 3x. Alright, this would make 13 or 7, but not 11. So the 1 times 10, even though it looked at first like I could definitely make 11 out of it, actually I cannot make 11 with it. Alright, so I have to forget about the 1 and the 10. Alright, instead it must be the 2 and the 5. Okay. Now inner I have 2x, and outer I have 15x. Can I make 11 out of this if I choose the signs right? No. 15 minus 2 is 13. It's close, but no. So let's try it the other way around. Let's try it with 5 here and 2 here. Now inner I have 5x, outer I have 6x. Ah, there we go. If I make this positive and positive, 5x plus 6x is 11x. So that means both of these will be positive. Check the sign of the 10. Positive 5 times positive 2 is positive 10. So this is correct. Okay, look for a GCF. 11 is prime, so no. Okay, so binomial times binomial. First term is 2y squared. That can only factor as 2y times y. Now the third term is 12. So 12 can either be 3 times 4, or it could be 2 times 6, or 1 times 12. Okay, you might be thinking, oh, 1 times 12, because that'll make, I could make 11 out of 1 and 12. 12 minus 1 is 11. But because of this 2 in the front, that type of thinking doesn't work anymore. So we have to, let's just go through the process, remembering that inner plus outer equals middle. So I'm going to just go in order and start with the 3 and the 4. Okay, by the way, I want to talk to you about a shortcut. 3 and 4. I always have to ask myself, will it be 4 and 3 like this? Or will it be 3 and 4 like that? Let me tell you why. At a glance, I know that the 4 and 3 option does not stand a chance. And that's because, look at the first set of parentheses. Do you see how 2 and 4, there's a common factor here? They're both divisible by 2. If there's no common factor in the original problem, there should never be a common factor inside the parentheses. So you wouldn't put a 4 here, because you already know it won't work. So instead, you'll only try this option. So by avoiding the ones that you know ahead of time won't work, you will save many minutes. Okay, so anyway, inner plus outer equals middle. So inner, I have 3y, and outer, I have 8y. I'm trying to get positive 11y. Well, if I just leave them positive, positive 3 and positive 8 makes positive 11. So that means these are positive. Now, we have to make sure we're getting positive 12. And we are. Positive 3 times positive 4 is positive 12. So this is correct. Alright, number 14. Look for a GCF. Wait a minute, there is a GCF this time. All of these are divisible by 3. So 3 is the GCF. So when you have a common factor like that, you need to pull it out first. So we're going to put a 3, and then we'll make parentheses, one set of parentheses big enough for the entire trinomial. To figure out what goes on the inside, we will mentally divide each term by the GCF, which is 3. So we will divide each of these by 3. Okay, so these 3's would cancel out. So that will leave me with m squared, and then plus 6m, and then plus 8. So we have that. Okay, and now we just continue. So we will keep the 3, but we will continue on with our binomial times a binomial situation. Okay, m squared can only factor as m times m. 8. 8 is either going to be 2 times 4 or 1 times 8. Well, that was weird. Let's try the 2 times 4. Okay, inner plus outer equals middle. Inner, I have 2m. Outer, I have 4m. Right away, I see that'll make 6 if I just leave them both positive. So that's what I'll do. Then I have to make sure I'm getting a positive 8. I am. Positive 2 times positive 4 is positive 8. So including the 3, don't erase that. This is the correct answer. Alright, number 15, last one. Is there a common factor? No, 5 is prime, so is 23. No GCF. So we'll go straight to binomial times a binomial. Okay, what am I thinking? Yeah, 5c squared, spaced out for a second there. 5c squared can only be 5c times c. Now 18, on the other hand, has some options. It's either going to be 3 times 6, or it could be 2 times 9, or 1 times 18. Alright, I'm just going to go in order. So let's try 3 times 6 first. Remember, inner plus outer must equal the middle. So let me circle that. Inner, I have 3c. Outer, I have 30c. I can control the signs. Is there a way I can choose the signs so that I get 23c? Nope. If I subtracted, that would make 27, but that's not that's not good enough. Alright, so that means the 3 times 6 option is not working. So let's try switching it around before we give up completely. So let's try 6 times 3. Inner plus outer equals middle. So inner, I have 6c, and outer, I have 15c. If I add those up, I get 21. 21? No, I'm not. So that doesn't work. I need 23. Alright, so that means the 3 times 6 option did not work. So let's try 2 times 9. Inner, I have 2c. Outer, I have 45c. Now, that's not going to make 23 no matter what the signs are. Alright, but before I cross it out, let's try switching it around. Alright, the 9 and the 2. Alright, inner, I have 9c. Outer, I have 10c. Okay, that's only going to make 19, so no bueno. No bueno. Okay, so that brings me to the last option. Okay, 1 times 18. Now I know if I put 18 out here, I'm going to have outer. Like 5 times 18 is a huge number. So I'm not going to try that. I know that's not going to work. So, but I'll try 18 times 1 like this. Trying to get 23. Inner is 18c. Outer is 5c. Okay, alright. 18 plus 5 is 23. So if I just leave these both positive, that will make positive 23c. Am I getting my positive 18? Well, yes, positive 18 times positive 1 is positive 18. Okay, so that's the answer for number 15. That's the end of this video. Alright, in part 3 of our lesson, we will tackle a word problem, a real world problem involving a rocket modeled by a quadratic function. So check back with me for that. I will see you on the next video.